Most people think AI works like this. You ask a question, the AI gives an answer. Conversation over. But the next generation of AI does something very different. Instead of answering questions, today we are stepping into one of the most important ideas in modern AI. For the last few years, most AI systems have been conversational. You give a prompt, the AI generates an answer. That is powerful, but it is still limited. Because real work usually requires multiple steps: researching something, comparing information, running calculations, checking results, producing structured output. Modern AI systems are starting to handle these workflows automatically. And that is where AI agents come in. Agents are AI systems designed not just to respond, but to complete goals. It plans tasks, uses tools, collaborates with other AIs, and actually completes work. These systems are called AI agents, and they are quietly becoming the engine behind the next generation of software. In this module, we will break down exactly how these systems work. By the end, you will clearly understand what an AI agent really is, what makes an agent advanced, how agents use tools, why companies are building multi-agent systems, and how modern AI products are powered by them. Once you see this architecture, you will start recognizing it everywhere. Let's begin. Let's compare two different ways AI can operate. Traditional AI looks like this: prompt, answer. You ask a question, the model generates a response, and then the interaction ends. This is called single-turn reasoning. But advanced systems work differently. They start with a goal. Then they break the task into steps. They plan actions. They use tools. They evaluate results. And they continue until the goal is complete. So instead of prompt, answer, you get something more like goal, plan, act, observe, improve. This is called agentic AI. It transforms AI from a conversational interface into a task completion system. Not all agents are created equal. A basic agent performs one reasoning cycle. It receives a prompt. It produces an answer, and then it stops. That is useful for simple tasks, but advanced agents introduce several powerful capabilities. First is multi-step planning. Instead of answering immediately, the agent breaks a task into smaller steps. Second is tool usage. The agent can interact with systems outside the model. For example, search engines, databases, code, environments, external APIs. Third is memory. The agent remembers previous steps and keeps context. Fourth is task orchestration. The system coordinates multiple actions to complete complex workflows. A good mental model is this: basic AI answers questions. Advanced agents run processes. Every advanced agent system rests on four key pillars. Understanding these four pieces will help you understand almost every agent architecture. First is the goal. The system needs a clear objective. For example, generate a market analysis report on electric vehicles. Without a goal, there is nothing to plan. Second is reasoning. This is the planning engine. The agent decides, what information do I need? Which step comes next? What tool should I use? Third is tools. Tools allow the AI to interact with the outside world. Fourth is memory. Memory allows the agent to remember previous actions and maintain continuity. Together, these four components enable AI systems to run autonomous workflows. Now that we understand the four pillars of advanced agents, let's look at what an actual agent system looks like under the hood. Think of this diagram as the internal architecture of a working AI agent. At the center of the system is the AI model itself. This is the reasoning engine, the part that understands language, analyzes problems, and generates decisions. But the model alone is not enough. First, the system receives a goal from the user. For example, Research the best solar energy companies in Asia and create a summary report. That goal enters the agent. Inside the agent, the planner breaks the task into steps. The system might decide, first, I need information. Then, I need to analyze it. Then, I should produce a report. To gather information, the agent uses tools. These tools might include web search, code execution, APIs, or databases. Each time the agent uses a tool, it receives new information. That information flows back into the model, where the reasoning process continues. Another important component is memory. Memory allows the agent to remember previous steps. Without memory, the agent would repeat the same actions again and again. With memory, the agent builds context as the task progresses. So the workflow looks like this. Goal comes in, the agent plans. The agent uses tools. Results come back. Memory stores progress. The agent continues reasoning until the goal is complete. This architecture is the foundation behind most modern AI agent systems. Once you understand this structure, the rest of the agent ecosystem becomes much easier to understand. And now we are ready to explore one of the most powerful parts of this system, tools. Tools are the element that truly transforms AI capability. Without tools, an AI can only generate text. It cannot access fresh information. It cannot run calculations. It cannot interact with software. But when you give AI tools, everything changes. For example, an AI agent might search the web for current information, execute Python code to analyze data, query a database, call an external API, read or write files. Think of the AI model as the brain. Tools are the hands. The brain decides what to do. The hands perform the action. Once tools are available, AI can move from thinking to doing. One of the most important ideas in agent design is the ReAct loop. ReAct stands for reasoning and acting. Instead of responding once, the AI works through a cycle. Step 1. Think. The agent analyzes the current situation and the goal. Step 2. Plan. It decides the best next action. Step 3. Act. The agent calls a tool or performs an operation. Step 4. Observe. It examines the result of that action. Step 5. Refine. The system updates its plan. Then the cycle repeats. This loop allows agents to adapt dynamically. They are not locked into a single response. They learn from each step of the process. That flexibility is what allows agents to solve complex tasks. Sometimes one agent is not enough. Complex problems require multiple specialized agents working together. Think of it like a team inside a company. Each member has a specific role. One agent might focus on research. Another agent might focus on writing. Another agent might analyze data. Another might validate the final result. This design pattern is called a multi-agent system. It mirrors how humans collaborate in organizations. Instead of a single AI trying to do everything, multiple agents coordinate their work. The result is often more reliable and more scalable. Agent systems are already powering many products you use today. Take AI coding assistants. Tools like GitHub Copilot and Cursor can plan code changes, write functions, run tests, and debug errors. Another example is AI research assistants. Platforms like Perplexity or Deep Research gather information from multiple sources and produce structured reports. Customer support systems are also becoming agentic. An AI might read a support request, check account history, propose a solution, and update the CRM system automatically. Even workplace productivity tools are evolving into agent systems. Future AI copilots will coordinate emails, documents, calendars, and tasks. Agents are becoming the operating system for knowledge work. Let's make all of this real with a simple case study. Imagine we ask an AI agent to do this. Create a beginner-friendly report on the top AI trends in healthcare. Now, notice something important. This is not a one-step task. A normal chatbot might give you a quick answer from memory, but a research agent works like a structured worker. First, it understands the task. It asks, what exactly is being requested? Who is the audience? What kind of output is expected? Then it begins searching for information. It might use web search to gather trusted reports, news updates, and industry articles. But gathering is not enough. Next, it filters the results. Because not every source is useful. Some may be outdated, some may be weak, some may be repetitive. After filtering, the agent extracts the key insights. For example, which healthcare AI trends are growing? Where are hospitals actually using AI? What are the risks? Why does this matter to business leaders or beginners? Then, the agent drafts the report. It organizes the findings into clean sections. And finally, it validates the output. That means checking whether the information is accurate, balanced, and easy to understand. So, the key lesson here is this. The agent is not just writing a report, it is running a workflow. That is what makes agentic AI so powerful. A very easy way to remember this is search, filter, think, write, check. That is a strong mental model for many research agents. Developers rarely build agent systems completely from scratch. They use frameworks designed to support agent workflows. One popular framework is LangChain. It allows developers to connect prompts, tools, and memory into structured chains. Another is CrewAI, which focuses on multi-agent collaboration. Each agent can have a specific role and responsibility. There is also AutoGPT, which attempts autonomous task execution. Microsoft offers Semantic Kernel, which integrates AI capabilities into enterprise applications. And OpenAI provides the Assistance API, which supports tool usage and persistent memory. These frameworks provide the infrastructure needed to build agent systems efficiently. Now let's look at a tiny Python example. This is not a production-grade agent. It is a teaching example. Its purpose is to help you see the logic clearly. At the top, we define a very simple function called web search. In a real system, this would call an actual search engine or API. Here, it just returns mock search results. Then we define the agent itself. The function simpleAgent accepts a user goal. That is the task we want the agent to complete. Inside the function, the first thing the agent does is identify the goal. Then it creates a very simple plan. Search for relevant information, then summarize it. Next, the agent calls a tool. In this case, the tool is the search function. That tool returns information. The agent observes the result and uses it to produce a final answer. So even in this tiny example, you can already see the architecture we discussed earlier. There is a goal, there is reasoning, there is a tool, there is output. This is the skeleton of an agent. Now, of course, real agents are much more advanced. They may use multiple tools, memory systems, retry logic, validation steps, and multi-agent collaboration. But the core pattern is already visible here. And that is the big takeaway. Agents are not magic. They are structured systems built around a simple loop. Take a goal, decide a step, use a tool, observe the result, continue. That is the basic DNA of agentic AI. Despite their power, agents are not perfect. Building reliable agent systems requires understanding their limitations. One challenge is hallucinated tool usage. Sometimes the model might call a tool incorrectly or assume it succeeded. Another issue is uncontrolled loops. Agents may repeatedly attempt actions without reaching a conclusion. Agent workflows also consume significant computational resources. Each reasoning step requires additional model calls. Debugging these systems can also be complex. Developers must inspect reasoning steps, tool outputs, and memory states. Because of these challenges, production systems require strong evaluation frameworks and guardrails. Reliability must be designed deliberately. Software is undergoing a major transformation. Traditional software waits for instructions. Agentic software pursues goals. Imagine telling an AI system, prepare a quarterly market analysis. Instead of manually gathering data and creating slides, the AI agent would collect relevant data, analyze trends, generate visualizations, summarize insights, produce the report. All as part of a coordinated workflow. In the coming years, many digital tasks will be handled by AI agents working alongside humans. Understanding this shift will become a critical skill. Agents represent the next layer of AI innovation. Let's summarize the core idea from this module. Agents transform AI from conversation systems into action systems. 4 components make this possible. Reasoning. The system plans each step. Tools. The system interacts with real systems. Memory. The system maintains context. Collaboration. Multiple agents can work together. Once these elements combine, AI becomes capable of completing complex goals. That is the mental model to remember. In the next module, we explore another major breakthrough in modern AI: retrieval augmented generation. Large language models only know what they were trained on. They do not have access to your private documents or company data. RAG solves this by retrieving relevant information at runtime and injecting it into the model's reasoning process. This is how organizations build private knowledge systems powered by AI, and that is what we will explore next. If this module expanded how you think about AI, that is a good sign. Because the biggest shift happening in AI today is not just better models. It is better systems built around those models. Agents are the architecture behind that shift. Understanding them today will put you ahead of most people working with AI, and we are only getting started. Join us in our next module. If you want to learn more, visit our website www.thegeniuscircuit.com. Like and subscribe to get updates on our easy AI tutorials.